Assalamualaikum and salam sejahtera to Madam Annie and everyone. So today my group will present our group project for ITT569 Internet of Things that title Weather Monitoring. So this team consists of 3 members. The first one is Aina Maisara, the second one is Wan Nordiana, and lastly is me. My name is Nur Izzati Zahira. So we are from group 5E. Okay, so next we move to introduction. So modern technological advancement mainly concentrate wireless controlling and also monitoring of variety of devices over the internet, so that the internet serve as a medium for communications between all the devices. So the majority of this technology is geared towards effective monitoring and control of various things. So an effective environmental monitoring system is required to track and also evaluate a weather condition in the event that parameters like noise, carbon dioxide, radiation levels that exceed the set levels, as well as to collect informations for research purpose about like amount of rainfall, wind speed, or etc. The smart weather monitoring system is more affordable and also efficient than other products on the market. So the meteorological divisions, weather stations, aviations, marine and also agriculture industries can all benefit greatly from this project. So next we move to problem statement. So a weather station is required to measure the environment's temperature, rain and also UV light, as well as to regulate it. So the following issues are also included in the studies problem. So the first one is which IoT or Internet of Things platform should be used. The second one is sensor functionality, and the last one is system flexibility.
Next, for our objective of this project is to develop an Internet of Things based weather monitoring system that can send commands and receive sensor data. Furthermore, it is to test the sensor's functionality and design a system for the collection, analysis, and control of weather data. So for this project, we are combining 3 modules of sensors. Submodule 1 is temperature and humidity sensor. The sensor named as the DHT11 for the Arduino component. It can measure temperature and humidity in real time using high precision sensors and embedded microcontrollers. Next, submodule 2 is rain sensor. The rain sensor offers useful information in real time when integrated with the retractable roof. The sensor detects raindrops and opens the roof automatically in response. And last module is submodule 3, light sensor. The purpose of this sensor is to measure the light intensity of the sun emits. So next, I will demonstrate my module 1 for temperature and humidity sensor with automatic fan control. I'll be demonstrating a temperature and humidity sensor system that automatically controls a fan based on the environmental conditions. For this module, I use an Arduino Uno, DHT11 sensor, LCD display, a DC motor which is a fan, diode, 2N2222 transistor, a 220 ohm resistor, and jumper, also an others component. The DHT11 sensor measures temperature and humidity levels in the surroundings, and the Arduino processes this data and display it on the LCD screen. When the temperature exceeds a certain threshold, the system activates the fan to cool the environment. Here is the circuit diagram of the project. The DHT11 sensor is connected to pin 2 of the Arduino, and the LCD is connected via I2C communication to make it easier to manage. While the DC motor, which is a fan, is connected to pin 5 through a transistor and a diode for protection. The LCD will display the current temperature, and the fan will turn on automatically if the temperature reaches a certain threshold. So for our next submodule, which is the rain sensor, which is responsible for detection of the raindrop level presence, this module resistance gradually decreases with respect to an increase in the wetness on the board. As the resistance decreases, its output voltage also decreases with respect to the wetness of the module. So the rain module board consists of two pins used to connect to this control board, which later transmit to this rain control module as the rain board module detects water, and the control board is used to control sensitivity and compare and convert the analog values to digital values. We'll proceed here to our next components, which is our Arduino board that read the analog data of the sensor, and we can transmit the average rainfall on top of the sensor, which display here. Firstly, our first output, which is the LCD display to monitor, and second is our SG19 servo meter that will act our rooftop today for our submodule.
Now we will go to the demonstration of the last submodule of our group, which is light sensor. To implement this light sensor, I have used several hardware and software requirements. For hardware requirements, I use the first one is Arduino Uno. Next is jumper cables male to male and male to female. Next we use LDR, and then we have LCD. After that, we also use resistor, breadboard small, this one, okay, and lastly we use micro servo motor SG19. For software, it's the same as submodule 1 and 2, which is Arduino IDE IoT platform, and the data processing and analysis software with real-time capabilities. So basically, for this light sensor submodule, it will respond to the light emitted on the LDR. So the light emitted on the LDR will stimulate a direct response to the servo motor to execute the movement. For the output of this submodule, it will produce two outputs. First, we'll display the output on the LCD showing the curtain is closed or open. For the second output, it is an action on the curtain to open or close, and the movement is supported by servo motor. So we will witness the action of this submodule against light in the testing shortly.
So this is our smart home illustration. For testing the temperature and humidity sensor, firstly, power on the Arduino and the LCD initialize and display temperature of 33.30 degrees Celsius to indicate that the system is starting, and the fan status show the fan is off. Now the DHT11 sensor have measured the temperature and humidity. We can see the current temperature and fan status on the LCD. The humidity will display on serial monitor. Now I'm using lighter to heat the temperature of the DHT11 sensor. As you can see, the temperature is rising, and once it crosses the threshold of 34 degrees Celsius, the fan will turn on automatically to cool down the environment. The LCD display current temperature and fan status is on, which is hot weather. The fan has been active now, and it will continue to run until the temperature drops below the threshold. As the temperature lowers below the threshold, the fan will turn off automatically. In conclusion, the temperature and humidity sensor system with automatic fan control can help maintain a comfortable environment by regulating temperature and humidity levels. We will continue for our raindrop sensing module. We will test with few water droplets with this spray provided. Firstly, we will expect to see two different outputs for raindrop. Firstly would be the LCD display and the SG19 servo motor. Okay, here the LCD display the initial welcome of the rain status, and here our prototype rooftop also in the initial state, which is the wide open that indicates that the day is sunny and hot. We will begin our module by spraying the module, and then it will show that the rooftop will retract slowly, indicate that the rooftop is closing, and then it will shown here our LCD display that the rain status today is raining, and it is shown that the homeowner can be eased from having to go back and forth again to prevent the clothes from getting wet. So the rooftop will retract slowly to close to cover the laundry suspension. This happens as the raindrop calculated are more than 900 mm of water. So we immediately invert to the LCD here, rain to yes. And also state the initial status of the rooftop is closed based on the condition abide. Guys, if we dry the module, the status of the LCD will show yes to no, which sensor detect that the day is no longer raining. This indicates based on the condition if less than the 900 water droplets, it will open wide the rooftop and the status is no longer rain. In conclusion, the retractable rooftop is suitable for daily home necessities that is easy and quick action in helping users for future use.
Okay, next we move to testing of the light sensor. For this sensor, as I was told earlier, it will react to the light that is reflected on the LDR. This time, the testing was carried out in the illustration of a smart house that used light sensor at home. The demonstration also explained about the two output, which is the first one is the LCD shows the curtain close or open, and the second one is the curtain reflect on open or close, and the movement is supported by the servo motor. We will witness these two outputs. In this illustration, the light is sunlight or solar light. In this illustration as well, the curtain seems to be in one part of the house. Now we will shine light on this LDR. We can see the servo motor move the curtain to open when exposed to light, and the LCD shows for the curtain to open. Here we can see the curtain is wide open and the LCD shows the curtain is open. When the light is removed from the LDR, the motor servo moves the curtain again and the curtain close again, and even the LCD shows the curtain close. Okay, so let's see one more time. This is open and this one is closed. Again, this is open curtain and then this is closed the curtain. So that is testing the light sensor illustration in the smart house, so that when exposed to sunlight the curtains will open, and when not exposed to sunlight the curtains will be closed. In real life, it is like morning and night. At sunrise and in the morning, the curtains open, and at dusk to night, the curtain will close.
In overall, the IoT-based weather monitoring system created in this project has a number of important advantages, such as the capacity to deliver precise and real-time weather data, monitor environmental conditions, and aid sustainable development. To enhance the project implementations, we recommend that further studies be conducted to address. With all that being said, thank you and have a nice day.